Chapter 8, Straight Line. The objective of this video is to understand equations of straight lines. Let us focus on the middle graph. When we inspect the coordinates of every point on line 1, we can see that there is something in common. What is the common characteristic of every single point on line 1? Yes, you are right. The common characteristic is that all the x coordinates of the points are 1. All x are 1. When we express this common characteristic algebraically in an equation in terms of x, it is known as the equation of this straight line. So the equation of line 1 can be expressed as x equals to 1, which means that all the points that lie on line 1 must satisfy x equals to 1. If we have a point, for instance, A, where the coordinate is 2 and -1, we can see that the x value here is not 1. So it doesn't satisfy x equals to 1. In another word, it is not, yes, it is not on line 1. Now let's look at the right graph. When we inspect the coordinates, we can see that the y value of every single point on line 2 is equals to 1. So it can be written as all y are 1. And when this common relationship is expressed algebraically as an equation in terms of x or y, it can be written as y is equals to 1. And this equation now represents the equation of straight line 2. For line 3, when we examine the value of x and y for each point on line 3, we discover that the value of x is always equals to the value of y. And this is common to every point on line 3. So the common characteristic of this point can be expressed algebraically in terms of x and y. So the equation of straight line 3 is y equals to x, because all x is equals to y. In conclusion, all straight lines can be summarized as a single equation in terms of x and y, and that equation is called the equation of the straight lines, or sometimes it is called linear equation. Thank you. In the previous video, we have examined 3 straight lines and their respective equations. Now, let's add 3 more to the list. Let's focus on line 4. When we try to inspect the coordinates of the points on line 4, we discover that the y value is always 2 times bigger than the x value. Y value is always 2 times bigger than the x value. So here we can conclude that all y are twice the value of x. And when we translate this algebraically, we get y is equals to 2x. It also means that all y are twice the value of x. So this is the equation of straight line 4. Line 5. We start by examining the value of each point on line 5. And we noted that the value of y are half of x. For example, when the y is 1, the x is 2. So y is half of 2. 2 is half of 4. And 3 is half of 6. So now, let's translate these common relationships into an algebraic expression, which is equals to y is equals to x over 2. So this is the equations of straight line 5. Now let's try line 6. When you examine the coordinates, what can you see? Yes, you are right. All value of y are 3 times bigger than the value of x. And this statement can be written as y is equals to 3x. So this is the equation of line 4. Thank you. Look at line 7. Examine the coordinates of each point on line 7. We can see that the y coordinates are always 1 more than the x coordinates. All y are 1 more than the x. So this can be summarized as y equals to x plus 1. And this is the equation of straight line 7. Now, look at line 8. Examine the coordinates of each point. We can see that all y are 3 more than the x, and this can be written algebraically as y equals to x plus 3, and thus this is the equation of straight line 8. Beside the straight line equation, we can notice something interesting here. First, in the equation of the straight line, we have a y term, x term, and a number term. And in the straight line equation for line 8, also we can see a y term, x term, and a number term. And let's look at the number term for line 7. The value is 1, and it is equals to this value. In other words, the number term of the straight line equation is equal to the y value of the intercept of line 7 and y-axis. Let's look at line 8. The value of the number term is 3, and the y-intercept of line 7 also equal to 3. So we can conclude that the number term of straight line equation is equals to the y-intercept. So if we have a sketch line, for example like this, and here the value is 6, this is y equals to mx plus c. From the two examples given above, we know that c refer to the y-intercept, and the y-intercept refer to the value here, which is 6, and thus we can conclude that c is equals to 6 in this example. And thank you. In this video, let's examine two more lines, line 9 and line 10. For line 9, let's inspect the value of x, and x equals to 0, 1, and 2, and so on. Apparently, we cannot see any common characteristic, but if we try to multiply the value of x by 2, so 2x equals to 0 here, 2 times 1 equals to 2, 2 times 2 we get 4. Now things become more obvious, because when we compare the value of 2x with the value of y, we can see that the value of y is always 1 more than the value of 2x. For instance, 3 is 1 more than 2. 5 is 1 more than 4. So we can do this, 2x plus 1. So 0 plus 1 we get 1, 2 plus 1 we get 3, 4 plus 1, we get 5, and so on. And since this expression gives us the value of the y, so we can write the equation as 2x plus 1 equals to y. Thus, 2x plus 1 equals to y is the straight line equation for line 9. And do remember that the number term in the equation is always equals to the y-intercept. The number term of the equation is always equals to the y-intercept. What about line 10? Let's examine the value of x from 0, 1, 2, and 4, 2 and 4, and so on. Apparently, we cannot see any relationship again if we try to compare the value of x and the value of y. However, if we divide the value of x by 2, then we get 0, 0.5 when the x is 1, 2 divided by 2 we get 1, 4 divided by 2 we get 2. When things appear suddenly, well, let's look at the value of y, 1 and 0. What can you see? Yes, the value of y is 1 more than the value of x over 2. What about 1.5? Yes, again, 1.5 is 1 more than 0.5. And these apply to the rest. 2 is 1 more than 1, and 3 is 1 more than 2. So which means that if you add 1 to x over 2, then we can get the value of y, which are 1, 1.5, 2, 3, and so on. So what is the straight line equation for line 10? Yes, you are right. It is y equals to x over 2 plus 1. And remember this, the number term is always equals to the y-intercept. In this video, we try to find the gradient of line 9 and line 10, and we try to compare the value of the gradient with the equation. The purpose for us to do this is we would like to see what is the relationship between gradient and the equation. Well, for line 9, the gradient is equals to rise over run. And yes, you can pick any 2 points. For instance, I pick 1, 3 and 2, 5. So the rise is from 3 to 5, which is equals to 2 units, and the run is from 1 to 2, which is equals to 1 unit, and the gradient is equals to 2. For line 10, the gradient is equals to rise over run again. And now I want to pick 2 points, and these are the 2 points I would like to use, 0, 1 and 4, 3. The value of rise is from here to here, which is equal to 1 to 3, 2 units, and the run is from here to here, which is from 0 to 4, which is equal to 4 units. And thus, the gradient of line 10 is equal to 1 over 2. Now, let us look at the value of the gradient and try to compare it with the straight line equation. We can see that the gradient is equals to the coefficient of x term, coefficient of x term, and these apply for line 10 as well. When the gradient is 1 over 2, the coefficient of the x term is also 1 over 2. And do remember that this can be written as y equals to 1 over 2x plus 1. So now, from this video, it should be very obvious to you that the gradient of the straight line is also stated in the equation as well as the y-intercept. So which means that in a straight line equation, we can read the gradient, which is always the coefficient of x term, and also we can read the y-intercept, which is the number term. So this is the relationship between gradient and the straight line equation. Thank you.